All right, so let's graph some hyperbolas. Our first example is x squared over 9 minus y squared over 16 equals 1. So first thing we'll want to take note of is when our hyperbola equation starts out with an x squared first, in that first term, that means that we will have a horizontal transverse axis, and our hyperbola will open horizontally, so left or right. All right, our a squared is equal to 9, so that means that a is 3, and our b squared is equal to 16, so b is 4. Okay, so we have a sense of what this is going to look like. The hyperbolas are going to open left or right. When we graph these, we're going to start by finding the asymptotes. Now, if your transverse axis is horizontal, the equation for your asymptotes is y equals b over ax, plus or minus. So what we do is we plug in our b and our a value. So one asymptote will have the equation y equals, our b is 4, over the a is 3. And the other asymptote is y equals a negative 4 over 3x. So we're going to graph those two lines. The y-intercept is 0. So I'm going to graph the first one, y equals 4/3 x. So your y-intercept is 0. Your slope is 4/3. So you're going to go up 4 over 3. And then go up 4 over 3. Then we're going to get the rest of our line by going down 4 to the left 3, down 4 to the left 3. When you draw on your line, I recommend using a ruler or fold a piece of paper for a straight edge. It's just going to make your graph so much nicer if these are straight lines for your asymptotes. All right, there's my straightest line I could draw. If I wasn't on an iPad, I would be using a ruler, so this looked nice. Okay, so that's the asymptote with a positive slope. Now we need an asymptote with a negative slope, so negative 4/3. So the y-intercept is 0. Now our slope is negative 4/3, so down 4 to the right 3, down 4 to the right 3, and then get the points on the other half of your line, up 4 to the left 3, up 4 to the left 3. All right, so you notice I drew these as dashed lines. That's a common way to draw asymptotes. I suppose if you drew them solid, I'm not going to mark you off for that, but that's just, you'll see them as dashed lines quite often. All right, so first step done, we got our asymptotes. Next, we're going to get our vertices. So what we want to remember is the vertices, our a value tells us how far away the vertex is from the center. We've already identified that our a value is 3. So from the center, we're going to go 3 units away. Because our transverse axis is horizontal, these will be on the x-axis. So our ordered pairs are going to be a positive 3, 0 and a negative 3, 0. So we can plot those points, positive 3 and negative 3. Next, we need the foci. We know that the foci is c units away from the center, but we don't know what c is. So we're going to need that Pythagorean relation. It's c squared equals a squared plus b squared. So c squared equals, we know that a squared is 9. We know that b squared is 16. 9 plus 16 is 25. And if we square root both sides, we're getting c equal to 5. Now, the foci is an ordered pair on the transverse axis as well, so that's going to be on the x-axis. So we have 5, 0 and negative 5, 0 as our foci. And I'm going to make those in a color that we'll be able to see better on the graph. So when I plot the foci, I am going to put an F next to those because I just want to make sure I remember that's the foci that's going to go inside of our curves. All right, now we can draw our hyperbola in. it's going to go through the vertex and it's going to approach the asymptotes. So if I look at this vertex on the right, I'm going through, I'm approaching the asymptotes in a curve-like fashion, like that. Then we are going to make one on the other side, go through your vertex, approach the asymptote, but don't touch it. Approach the asymptote, but don't touch it. All right, look at that beautiful hyperbola. All right, let's take a look at one more. The transverse axis was horizontal, so I want to make sure we understand if your transverse axis is vertical. So in this equation, y squared over 4 minus x squared over 36. So if our hyperbola equation starts with a y squared, that means that our transverse axis is vertical. That means that our vertices and foci will be on the vertical axis. But let's identify some things. That a squared is equal to 4, so we know a is 2. This is our b squared equal to 36, so b is 6. All right, first thing we find are those asymptotes. When you have a vertical transverse axis, the asymptote equation is opposite of what we just did, or kind of flipped. Y equals plus or minus. The a over the b creates our slope with our x. So let's write our two asymptotes. One of them is y equals 2 over 6. Now I'm going to write it over here, 2 over 6. If you can reduce that, let's reduce it. So that's going to reduce to 1 over 3x. And then the other one is y equals a negative 1 over 3x. All right, so when we graph our asymptotes, where the y-intercept is at the origin, then we're going up 1 to the right 3, up 1 to the right 3, down 1 to the left 3 to get the rest of that. We get a nice straight edge. We draw these in. You guys can show off your nice, neat graphs tomorrow. All right, so there's our y equals 1/3 x asymptote. The other one is a negative 1/3 x. So back at the origin, we go down 1 to the right 3, down 1 to the right 3. Backtrack to get the other half, and we are going to draw in our asymptote. There we go. All right, so next we find our vertices. The vertex is a units away from the center of your hyperbola, so we need to know our a value is 2. So the vertices will be 2 units away, but because the transverse axis is vertical, the vertices will be on the vertical axis, so on the y-axis. So those ordered pairs would be 0, 2, and 0, negative 2. So here's 0, 2, and here is 0, negative 2. After the vertices, we find our foci. Foci uses our c value, which we don't know, so we can use that Pythagorean relation. C squared equals a squared plus b squared. So c squared equals our a squared is 4. Our b squared is 36. So 4 plus 36 is 40. Square root both sides. So c is equal to the square root of 40. However, we can reduce that with a square root of 4, square root of 10. So c is equal to 2 root 10. Now the ordered pairs for the foci, those are on the transverse axis as well. So on the y-axis means the x is a 0. There's our positive 2 root 10, and then 0, negative 2 root 10. Now, we need to graph this, right? So where is a 2 root 10? That's when you would type that into your calculator and say, all right, I know that's about equal to 6.3. So we're going to graph the foci at 6.3 and we're going to label it F so we don't confuse it with the vertices. So I'm going to go up from the origin 6.3 units. There's one focus, and then I'm going to go down from the origin 6.3 units. There's your other focus. We draw in our curves going through the vertex, heading toward the asymptote, through the vertex, heading toward the asymptote. You might notice that this hyperbola has curves much wider. Well, similar to the parabolas, if your focus is further away from the center, or yeah, that's going to widen those. So that's why that looks kind of wide like that. But there you go.